what he drew, and I made them the same size. See how the triangle's the same size? I thought, okay, now let's put this into a sphere, see what happens. So I put it in, and sure enough, it doesn't. It works. So it just so happens that my form has a triangle on the bottom of it too, the same size. So I put it in the sphere. Perfect. I didn't have to do anything to the tetrahedron. I just took my form, made sure that it was the same size to test this out. Okay. So if that's the case, okay, here are the three. Here shows the bottom are the same. I put it in a globe. I want to find out where this is. So I put it into a sphere, but a plastic globe that shows all the continents to find out what's going on. And he said that one of the points hit the South Pole, of course, and the other point hit Japan, right here. Then he said the other points, one of the points was in mid-America, and the other point was somewhere in Russia. Well, he said mid-America was here. Now, wait a minute. That's not working out at all. That's not consistent with what he's saying. But then I found out that what he does is he always gives two different versions. And I've asked one person why that is the case. Why did he always give two versions? And he said the reason is that nobody could copy me. They wouldn't know which one to copy. So I ignored this, and I went across, and he said it was in mid-America, which is mid-America, he said. But mine came out in the mid of America, right in the middle, Kansas. And the other one went over into Greece, actually the Aegean Sea. Okay, so that's interesting. And the reason it's interesting is because you have to remember that everything, all the energy comes from points. That's where all the growth of the Q-tips work. So what I decided to do is to study the points. And I looked at the points, and I saw that at the South Pole, you have this cap. I mean, there's no doubt about it. That's a cap right there. And what these studies are is that now that the satellites go over the Earth, and they photograph it right through the water, right into the Earth. So here it is. There's a triangle on the top. There's a triangle hole at the top of the Earth. Now that's what this is saying here, is that is a triangle. And at the bottom here, that's a point. I mean, we're talking about a cap here. So if you look at this, I brought these so you can really see these up close. That is definitely a cap. And at the other end, it is a triangular hole. So this is going against a whole bunch of stuff that the scientists are saying. All right, so I also noticed that this is Tornado Alley. And Tornado Alley always goes right from here to Kansas and then takes a right turn. So if I take the form and look at it, okay, find America here. There's the line that it follows, and it goes right to Kansas, and then it goes over on this line. So the tornadoes are following this edge and then turning the corner. The scientists don't know why that turns there. They think it's because of the weather. Imagine the weather having an effect on a tornado. Okay, so tornadoes follow lines. Now when you see one tornado going along, you think, well, it's not following anything. And then you see two, well, maybe they are. If you put three, then you could see that tornadoes follow a line. Well, that was good news. Then this came out. I couldn't believe it. Right at the same time, it says, sculpting the Earth from inside out. Well, that's perfect for me. So I saw this drawing here. This is what they're saying, that this part of the Earth right here is very deep and cold. These are deep roots, very deep in here. And this is very magna. This is very fluid and very, very hot. and the yellow is in between. They did a CAT scan of the Earth. This is what they do now. So I went to this article and found out that this guy who did this is at California Institute of Technology, LA Tech. I drove down here and I asked him what's going on. And he says, I said, why is this here? What is this? He said, well, we have no idea. All we can do is measure, you know. So I decided that to flatten out my Earth study here, which I can do just on a map, and I flattened it out, and I found out that here's the lines that follow the shape right down that line. Here's another point here. Here's the other point that's coming, and it's going down here. Here's the other point. And this is how the deep roots, okay, could be associated with this form. You know, how I can't get a shovel and figure this out. The only thing I can do is things like this. Okay, so this idea that there is this big magnet in the world, and all the energy flows in like this, and in like this, and out like this, is, I don't find that to be the case. This is all based on a magnet idea. So what I had found was that this form, I can put a cone in here, and see how it touches the end? I can take a cone and put it on the outside, like that. So what it's saying is that these points and the circle inside that makes the vortex are parallel. And so the way you can show that is to show it's the same cone. It's the same cone. That's amazing. And that if I cut this cone, when it hits the very bottom of the form, and then I cut this off and put it in the bottom of the form, this is what it looks like. You've got a big cone that runs on the outside, the top view, and a little cone comes down the end and meets at the very bottom, and this cone is the same size as this one. Well, that makes sense because when you put these two together, they should be the same size cone. And they are. That red line I just cut off of the razor blade. What's amazing is I can put this into the sphere. I can take this one and put it on the outside of that, put it together, and all of those forms, all those cones, made perfect. They don't wiggle, nothing. Now what's happening is that there is a vortex that's coming in the top of the Earth, okay, or if this is true, there's a vortex that's coming in the top, just like these guys say. But it's not coming out the bottom because the bottom hits a cap. But the vortex that's coming from below the Earth is coming up into this circle. Sorry, this circle. I'm sorry, this is the top where the vortex goes in, and at the bottom, the vortex is coming into here. And it's going out. I see why I got this confused, why I'm confused. Because I put it in wrong. I have to work on these things too, you know. Even when I'm demonstrating, I'm working. It's crazy. All right. So what's happening at the top of the world is you have a vortex running in. At the bottom of the South Pole, you have a vortex that's running inside here and coming out into the second ring. Now, I'll explain this a lot better because this is cool. Now, first thing I want to show you is how this comes in. So I made one of these things, I made the Earth, and I put the form in there, and I put it inside. Then I put it into water to see what's going on. So I just so happen to have an electric drill. And I'll show you what happens. you'll see a vortex that comes into the top, but it will not go all the way out to the second circle because the first circle stops it. Well, the vortex will be forming now, and it goes lopsided here. See that vortex go in? I'm going to put this at the bottom, which I used to do. I had a thing down there that would keep it stable. See if I can find it. Okay. There it goes right down into it, right down to the bottom, and it does not go into that circle that's forming around it. And if it does, watch what happens. It starts to spurt out, not starts to splurt out, and it will not allow it to go down any further than the very tip. And I'll show you another view of that. I have another form that you can see through the, you don't have the earth in the way. Same form without the earth around it to see what it does so you can see through it. Thing's really powerful for a little wire sculpture. Now, the vortex will come down, and then it will not allow itself to go into too deep in there before it starts to spread all the way around like this. So it's a governor. It keeps the earth at a constant rate of speed. Now, you know that's not a circle, that's a triangle. Now, I asked you guys to get me some glitter, but I'm afraid it's too thin. Not thick enough, but I'll do it anyway. Yeah, see, it's too thin. But one of the things I want you to see, and I don't know if you can, but there are 3 vortexes that are turning inside there after I stop it. Yeah, there they are. There you can see that there's a main one and there's 2 others that go around it. Now, one of the things that the glitter does is, if it was thicker, is that it shows what happens when this turns and the vortex goes inside here. The glitter comes up through this side and comes out these 3 corners. And that makes up the circles. You have energy coming in here and energy coming out here, but not at the bottom. You only have a force coming in from the bottom. Now you're going to think, well, what is this force? Look, if I take this and I put this spoon on here, okay, but if I flip it around, if I flip this around, then oh my gosh, look. Why is that? There's a force there, a magnetic force that you can't see. You can't see it, can you? But it's there. Look at it. So these are forces that you can't see. Now you have to remember that lightning you can see day and night, okay? The rainbow you can only see in the daytime because this deals with light. And the aurora borealis you only can see at night. But the forces are there. So when I say that there is a force that's coming in the top of the sphere, another one coming out the top in the opposite direction, it looks like this. Okay, this is the force that's coming in from the bottom, and this is the force that's coming in from the top. And if you look at these spirals, they're in opposite directions. And this is what's happening inside the Earth according to this study. This drives the scientists crazy. So this is what is happening, and what's wonderful about that is exactly what's happening in your heart. It has the same force that's going on in your heart as this one right here, except the distance from here to here are muscles.